Okay, this video is going to show you how to use a standard normal distribution, the idea of that, and something called a z-score to help you normalize data. So I mentioned in the last video, well, what happens if I ask for the percentage of people or things or animals or whatever we're talking about, and in between two numbers that are not fitting nice and pretty on our nice 34%, 13.5% percentages on our normal curve within exactly one standard deviation. What if the number is 1.5 standard deviations or 1.7 standard deviations? What do you do then? Okay, so this is how you handle that. I'm going to do an example, and hopefully you'll see how you can use something called a z-score, which is a calculation you have to make that will calculate how far away you are from the mean, and then you can look up in a table what that percentage is. So here's the problem. We have scientists conduct an aerial survey of a seal sanctuary and record the number of seals they observed. The number of seals observed were normally distributed with a mean of 73 and a standard deviation of 14.1 seals. Find the probability or the number of seals that at most 50 seals were observed during a survey. So we have to look at that, we have to find that percentage, okay? At 50. So let's take a look at what that would look like. So here I've put the standard deviation was 73. I've added 14.1 to each of these to get these numbers. But what we're being asked for is not like what percentage or what's the probability that if we randomly picked a day and looked at and counted seals that we would count but somewhere between 58.9 and 73 seals. I mean, it's not asking that. If it did, we can just take that percentage of 34%. It's asking us what's the percentage that we would see 50 seals. 50 is not on here, okay? 50 is somewhere in between. Let's see, I'll put it, it's about right in here. Oops, sorry. Undo, let me do a line. So it's about somewhere in between here. Okay, so right about there maybe. Okay, it's not perfect, but that's where 50 is. Not on some nice pretty number that we were doing before. Okay. So what we're looking for is what's the probability that we would see at most 50 seals. So at most means it could be 50 or less. So this is the area we're looking at. We're looking at this area right here, this and this and this. Well, here's the problem. We know what this is and this is. This is 34, and this percentage right in here in this big part is 13.5. But I don't know. I mean, this is right in between there. So there's something less than 13.5, and then we have the 2.35% and the 0.15%. So I need to know this area here, and it's in a weird spot. So what we're going to do is we're going to find the z-score. What the z-score is going to tell us is exactly how many standard deviations I am from the mean. How far am I from 73? Am I one standard deviation? I'm in between 1 and 2 standard deviations. So the number I'm going to get for this is going to be between 1 and 2. So to calculate that, it's a really easy calculation. You take the number that you've got, which is 50. You subtract the mean, which in this case is 73, and you divide by the standard deviation, which is 14.1. Okay, and when you do that, oops, what did I do that for? 14.1. Then when you do that, you get a number about it's negative 1.63. Come on, work with me here. There we go, negative 1.63. So you are, negative means you're in the negative direction. You are 1.63 standard deviations from the mean. This is 1 standard deviation, so this red line is 1.6 standard deviations from the mean. Okay, so that still doesn't help us find out the percentage, but luckily all of those percentages have already been calculated for us, and we can look them up in a chart. So the chart is actually in your book. I'm going to show you where that is. And I also have the one that I need the information I need for this one right on this in the next couple slides. Okay. Okay, so here is the chart, and this is part of the chart that's in your book. So what you do, we had negative 1.63. So what you have to do is look up the negative 1 here, and then anything after the point is up here. So negative 0.6 is 0.0548. So 0.0548, I'm going to go back here, 0.548. That is not a percentage, so that is about 5.48%. Okay, so that means, and that's giving me the area from here to here. So it's giving me the probabilities from this line all the way to the left. So the probability that I see 50 seals or less is 5.48%. Okay. The chart is in your book as well. So here's your online book. It's on page 401 of your online book. You can use this chart right here to look them up. You have the whole number here and the decimal point here. You have to round to the nearest tenth in order to do that. And then that'll give you the probability of everything to the left. What if you needed something, let me go back here. What if I asked for, the question was at most we saw 50 seals. What if I said, what's the percentage or the probability that we see 50 or more seals? So that would mean we're from this point all the way over here, okay? How would you do that? Well, the chart's going to give you the 0.0548. It's going to give you the percentage here. If I want the percentage over here, I'm going to have to subtract that from 1. So if I wanted at least 50, I would have to take 100% and subtract 5.48% from that. So it's going to be about 90, it's going to be 94.52%. Okay? So you have to subtract, if you want this area to the right, you're going to have to subtract it from 1, the decimal from 1, or the percentage from 100%. If you want something in between, so you want something in between here, and like let's say you wanted something, let me do a line here, between, let's say, 75, you wanted to know what was the probability that I see between 50 and 75 seals. What you would have to do is you'd have to find out the z-score at 75 using this equation, find the z-score at 50 using this equation, look up the area to the left of the curve for the z-score at 70, subtract from it the percentage that you get from the z-score for the 50. Because if you have this whole area and subtract off this little area, that's going to give you the area in between. Now it's a little confusing, but we'll work on that one. You might have a little trouble with that problem, that type of problem without me, but I think you can figure it out. So good luck with all this. Do your best.